Hey guys, this is Mrs. Harbin, and we are starting Algebra 1, Section 6.1. This is just going to build on Unit 5, and I think that you guys did really well with Unit 5, so we're just going to take that information and build on it a little bit more, so nothing totally brand new here, just building on what we previously learned. Let's start with a quick lesson opener. Go ahead and evaluate the expression 1/2 x minus 3 for the following values of x. So go ahead and plug and chug these in and then check your work. All right, when you plug in 2, you get -2. When you plug in -2, you should have gotten -4 as a simplified version. And when you plug in 1, you get -2.5 or -5/2 if you're leaving that as an improper fraction. So that's just a quick review of how to evaluate a function by plugging and chugging in a number or evaluate an expression. Let's try to evaluate this expression. -2x plus 5 for the following values of x. When x is 0, what does that simplify to? Hopefully you said 5. And when x is -1/2, what does that simplify to? Hopefully you said 6. If you struggled with any of those or you weren't sure what I was doing, make sure that you write that down and ask me what exactly we did there next class if you weren't following that we were plugging in the zeros and the 1/2 for x, but I think you guys probably got that. Our biblical correlation for this unit comes from Job 38:5, which says, "Who marked off its dimensions? Surely you know. Who stretched out a measuring line across?" And that is God talking to Job and saying, listen, Job, I made all this, I measured it, I put these rules in place. And we know that when we are studying math, what we're really studying is the patterns and the rules that have already been established by God, and that we can use these patterns and rules to help take care of his creation. And that includes making things safer for the people around us. And math is very useful for that. Our lesson objective for today is that you, the student, will graph linear equations on the coordinate plane using ordered pairs and determine the x and y intercepts of a linear equation. Now, this may sound like a lot of new vocabulary, but you've already been doing this information and doing these mathematical processes in the previous chapter. We're just maybe going to call it something a little bit different. So let's take a look at this and break this down. You're going to graph linear equations. Graphing you've been doing. Linear just means a line. An equation is what you've been doing. You've been graphing coordinates and connecting the dots to make a line. That's graphing linear equations. The coordinate plane, remember that's our Cartesian plane divided into 4 quadrants, 1, 2, 3, and 4. You've been doing that already. Using ordered pairs, yep, you've done that already. And determine the x and y intercepts. This is really the only new piece of information here. Determining the x and y intercepts. If you remember when we talked about quadrants, we said 1, 2, 3, and 4. We said sometimes you might have points that are not in a quadrant. They might be right on the line. Well, if it's on the x line, it's called an x-intercept. And if it's a point on the y line, here or here, that's called a y-intercept. So today you're going to actually determine the x and y intercepts of an equation. Now, you can probably look at a line and determine it, but you're going to learn how to determine that information just from an equation. All right, let's talk about graphing. By recognizing key characteristics of a function, you can quickly determine the shape and location of its graph. Linear functions have an x to the first degree, or an x prime, okay? That x is just an x by itself. There's no square, there's no cubed, there's nothing else there. So we have this linear function, f of x equals 2x plus 7. And if you remember, I said in a previous unit that f of x is just another notation for y. F of x and y are the same thing, because y depends on the x, or y is a function of x. So we have this linear function here, f of x equals 2x plus 7. These are called linear functions or linear equations because all the points that would work if we were to plug in an x and get a y, every single set of points would form a straight line. And we saw that again in our previous chapter. We were graphing points and then we were connecting those points. So in a linear function, or when you just have an x term to the first power, all of your points will form a straight line. Let's try an example and see. So let's graph y equals x plus 5. And they don't give us a domain, so we're going to make a chart and we get to choose our own x values here. So let's choose -2, and when we plug that in, we find out our coordinates -2, 3. When we plug in -1, plug that into our equation here, x plus 5, and we get 4, so our coordinate is -1, 4. When we plug in 0, we get 5, so our coordinate is 0, 5. When we plug in 1, we get 6, So 1, 6 is our coordinate, and when we plug in 2, we get 7. So 2, 7. This should look identical to what we did in chapter 5. Now they didn't give us a domain, so what we're going to do is graph this 5 points. And here they are, 1, 2, 3, 4, 5. And we will then connect them with a line. And as you can see, all of those points are on a straight line. So that is a linear function or linear equation. The standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers. X and y will be our variables because that's where we can plug in our x's to find our y's, depending on the information that we're trying to graph. But a, b, and c will be real numbers. Notice that there are no fractions and that a is positive. So in standard form, we want no fractions and we want our a, or the number in front of the x, to be positive. If a linear equation in standard form contains a fraction or a decimal, we'll get rid of those fractions and decimals by multiplying each term to turn them into integers. And we will do one of these on the examples here together, but we'll also do some in class. It is also common for a to be non-negative, so we will always do what we can to make sure that a is a positive number. So let's take a look at this example. We have f of x equals negative 5 over 7x plus 2. We're going to change this to standard form. The first thing that we want to do is get rid of this f of x and rewrite it with a y. So let's write y equals negative 5/7 x plus 2. The next thing that we want to do is get rid of this fraction. And the way that we get rid of a denominator is by multiplying by this number. So we're going to take this whole thing and multiply everything by 7. And when we do that, that changes our y to 7y. It changes our 5/7. The 7's will just cancel, so we're left with just the numerator, negative 5x, and 7 times 2 is 14. So we now have gotten rid of the fraction. Now we want our x's and y's on the same side. So to do that, we need to get rid of the 5x here on the right. And we do that using inverse operations, and whatever we do on the right, we have to do on the left. So we are left with 5x plus 7y equals 14. That is standard form. You can tell we cleared our decimal here, or cleared our fraction, and then we got our x and our y on the same side. The number in front of the x is not a fraction, and it's also a positive number, so we are finished. Let's try this example. We want to graph x plus 3y equals 4. Well, what we want to do is graph by making a chart. So the first thing I would like to do is rewrite this equation so that we have solved for y. When we rewrite that in terms of y, we're going to subtract our x from both sides, and then we will divide everything by 3 to get the y by itself, and we get y equals negative x over 3 plus 4/3. So let's go ahead and create a chart here. To find some ordered pairs, we'll use x equals negative 1, 0, 1, and 4. I'm going to plug and chug with our function there in the middle. And when I do that, I get these ordered pairs. I'm going through this very quickly. I'm not really showing you how to evaluate or plug and chug because you guys did a great job with that in chapter 5. I don't feel like you need to see all those steps. All right, once I have my ordered pairs, I am going to go ahead and graph those points and then connect them with a straight line. Now, I do get to connect them because I did choose my own domain values. I did choose my own x's. Remember, if you don't choose your own x's, you're just going to put dots. All right, so when graphing a linear function, let's quickly review the steps. First, we're going to solve the linear equation for y. Then, we'll make a table of at least 3 ordered pairs using convenient values for x. I typically do 5 and go negative 2, negative 1, 0, 1, and 2. We'll graph the ordered pairs on a Cartesian plane and connect the points with a straight line. Okay, guys, let's go ahead and take a look at some definitions. We talked at the beginning of the video about intercepts. The y-intercept, if you remember what I said, is the point, any point where the graph intersects the y-axis. If we're talking about linear functions, it's only going to cross the y-axis once. It could be here, it could be here, or a line could go this way, it could be here, but it's only going to cross the y-axis one point. So the y-intercept is the point where the graph intersects the y-axis. The x-intercept is the point where the graph intersects the x-axis. So again, it could be here, it could be here, but if you're graphing a linear equation, it's only going to cross the x-axis once. Remember how I told you that x was to the first power in linear equations? It was just x by itself. This little number right here actually tells you how many times it crosses the x-axis. So x to the first power means it's going to cross the x-axis once. Here's a challenge question. If we were graphing a function that had x squared, how many times would it cross the x-axis? Hopefully you said 2. We won't actually do any of those right now, but that's just a little kind of clue or heads up for future lessons. When we talk about a line's intercepts, we know that a line's intercepts can be found from the equation without graphing. So I already know that you guys can look at a graph. If you saw a graph of this and I asked you the intercepts, you could tell me the intercepts easily. But let's learn how to do it without graphing. If you think about it logically, at the y-intercept, our value of x is always 0. So at this intercept, x equals 0. At the x-intercept, what does y equal? Hopefully you said y equals 0. So if we know our x is 0 or y is 0, we can do some simple evaluating, plug and chug to find the intercept. So let's try to find the intercepts by using our standard equation. So 2x plus y equals 6. We've got it in standard form. To find the x-intercept, remember at the x-intercept, y is 0. So I'm going to substitute 0 in for y and solve for x. When I do that, I get 2x equals 6 divided by 2 on both sides. X equals 3. So our x-intercept is 3. If we were going to graph that point, it would be 3, 0. X is 3 and y is 0. Okay, now let's find the y-intercept. We said at the y-intercept, x is 0. So let's go ahead and substitute that in. And when we do that, we get y equals 6. So our y-intercept is 0, 6. Our x is 0, and our y was 6. Now we've got 2 points, so let's go ahead and graph those points. 3, 0, and 0, 6 way up here. We'll plot those points and then connect the dots to graph the line. So just by using those 2 points, we were able to graph the line. We didn't have to do anything else. No charts, no plugging and chugging, just finding those 2 points and graphing the line. An equation of the form y equals c, and c just represents a number or a constant, is a horizontal line. So y equals 3 would be a horizontal line where y equals 3. Y equals negative 3 would be a horizontal line at the spot where y equals negative 3. So when y equals a number, that's just a horizontal line. When x equals a constant or x equals a number, then you have a vertical line. So at x equals 3, for example, boom, 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 here's where x equals 3, so we draw a line right there. That is not a function, but it is a line. At x equals negative 3, we go to where x equals negative 3, and we draw a line because x equals negative 3 no matter what the y is. So remember that y equals a number is a horizontal line, and x equals a number is a vertical line. So let's graph y equals negative 2. Well, we would go to y equals where y equals negative 2, right here, and draw our horizontal line. Remember that y in this equation, y equals negative 2 regardless of the value of x. When x is 0, y is negative 2. When x is 1, y is negative 2. When x is 2, y is negative 2. It doesn't matter for all of our whole domain, y equals negative 2. All right, let's try graphing x equals 3. We go to where x equals 3, 1, 2, 3. And then we draw our line x equals 3. Now this is not a function. It does not pass the test to be a function, but we can see that regardless of the value of y, x is always 3. When y is 0, x is 3. When y is 1, x is 3. When y is 2, x is 3. X is always 3. Y equals negative 2 is a function because it passes the vertical line test, and like I just said, x equals 3 is not a function. It does not pass the vertical line test. All right, here are the things we did today. If you have any questions, be sure to ask me next class.